Hello everyone. If you watched my previous video about this car not starting in the cold weather on a cold morning, you must have seen that I wasn't really satisfied with not knowing what caused it. So I've decided to dig in a little bit and check some things out. So right now I'm going to check the ignition system and make sure it doesn't have a weak spark. And so I'm going to remove the coil and read the ohms on that, and I'm also going to remove the spark plug wires and check those out. But there's something else I have right here, which is this Sun dual meter engine analyzer. I picked this thing up back in like 1981, 1982 when I was young, and I thought it was the coolest thing ever. Now that I've had a chance to use it more and I'm more experienced, here we are 40 years later. I know it's not really much more than a toy, but I can actually measure on here the kilovolts in the spark plug wires. So let me show you what this analyzer has to offer. So this is a Sun engine analyzer. The information on the back states that it's made by Sun Electric Corporation, Consumer Products Division, Chicago, Illinois, made in USA. Remember, this is the early 80s. So there's two meters. They're both multi-function. And the top meter here will read two different ranges of RPM, the 1500 RPM range and the 6000 RPM range, depending on the selector switch. Each meter has a selector switch. It has a 20 volt range, a 2 volt range, so 20 and 2 volts. It's got a 1000 ohm range here and a 1 ohm range, which would be, looks like 100 ohms max. Then the lower meter here, you can read dwell. That's dwell on a points ignition system. Amps on a 100 amp scale, amps on a 500 amp scale, 15 kilovolts scale, and a 50 kilovolt scale. Now this kilovolt scale has a pickup that clamps onto the spark plug wire, and you can read the kilovolts that this thing is measuring going through the spark plug wire. So that's what I'm planning to do right now over here. See if we have a strong or a weak spark. As far as that 500 amp scale, I should probably explain there's a shunt that you can clamp onto the battery, and that's really just for reading cranking amps on the battery when you're having starting problems, or if a starter is going bad, you can read the amperage it's drawing to start the engine. But I'm not using that today. I'm going to start out on the 15 kilovolt scale, and I'll start out here on the 1500 RPM scale because we're going to be idling for this check. So let's get situated here and do this testing. So this engine analyzer has a positive and negative battery clamp that has to be on there to power the meters. This is the kilovolt clamp, and it just clamps onto the ignition wires. And this is an inductive pickup on the number 1 cylinder that's used by the RPM gauge. So I'm going to start it up now and we'll just see what kind of results we get. It's reading 1400 RPM on the low RPM scale, which means it's actually 700. And the reason it's reading double is because this is a wasted spark ignition system. It actually sparks on the exhaust stroke as well as the compression stroke. So it gets twice as many sparks as this thing is designed to comprehend. The thing I'm most interested in is the kilovolt scale there. And right now it's on the 15 kilovolt scale. And it's reading between 12 and 13 kilovolts on the number one cylinder. So that seems to me like it's surprisingly low. But let's check out the rest of them. I'll move this from cylinder number 1 to cylinder number 3. They're numbered 1, 2, 3, 4. So 1 and 3 are on this side, 2 and 4 are on this side. So cylinder number 3 is reading extremely low on the kilovolts. It's less than 2 kilovolts. You would think I'd have a really bad miss here. Does this sound like a bad miss? It's a little shaky. So it doesn't really sound like it's missing, and it certainly doesn't sound like it's missing while you're driving it. It also hasn't thrown any error codes, so it hasn't been misfiring significantly. Okay, let's move this thing over to cylinder number 2. Cylinder number 2 looks as bad as cylinder number 3 did. The spark is measuring less than 2 kilovolts. Alright, now let's move this back here to cylinder number 4. 1, 2, 3, 4. Driver's side toward the rear. And cylinder number 4 looks basically like cylinder number 1 did, 12 to 13,000 volts. So I don't really have a way of testing the accuracy on this Sun engine analyzer on the kilovolt scale. So maybe those numbers aren't exactly right. But what it does show is that 2 of the cylinders are much lower than the other 2. And I actually put this on my F-150 the other day, and it showed that it was reading around 15,000 volts, and that was on the center of the distributors as well as the individual cylinder ignition wires. So every spark that was coming out of it was 15,000 volts. My best cylinders here were around 12, 13, 14,000 at the most. So it would seem like the spark might be a little weak. At least it seems like the voltage is a little low. So anyway, this causes good reason to be suspicious that I have a bad spark here, or a weak spark at least. And it's time to check out probably the coil first, I suspect that. And definitely check out the ignition wires as well. I'll use an ohm meter to do that, and I'll show you how. And I'll tell you the specs. Okay, to help with giving me a little access to the coil, which is back here, I'm going to remove this air duct. It goes from the air filter housing back to the air box on the throttle body. All the intake air that this engine runs on goes through this duct. And you can't run without it because the mass airflow sensor is here. Okay. Pull these spark plug wires off. That seems like it's in perfectly good condition. I'm really hoping I find bad spark plug wires or a bad coil. I don't even want to think about what else it could be at this point. This thing out of the way a little bit. So these are 10 millimeter. There's 3 of them holding the coil on. That's what that looks like. And you can see on the top there, one of the bolts is all the way backed out already. That's how it was. Ratcheting box wrenches are extremely helpful in situations like this. There, that was easy. Pop these other 2 off of here. It's very easy to know where these cables go back on. This connector is a little tough. You have to give it a good squeeze on the latch there and pull it off. There's 4 pins inside there, and there's 4 sockets in there that the pins go into. Trying to get that set up so the camera can see it. That's the ohm meter. The coil was oriented down in there this way. So at the top were cylinder 1, cylinder 2, and then the bottom cylinder 3 and cylinder 4. So according to the manual, C and D here are cylinder 1 and 2, and that should be 11.2 K ohms plus or minus 15%. So that's 1 and 2. It's got basically 11.6 ohms. Haha. It's got basically 11.6 K ohms. Should be plus or minus 15%, so that seems very reasonable. Then between cylinder 3 and cylinder 4, that's A and B, It's the same spec, 11.2 k ohms plus or minus 15%. And I have 11.65 k. So that's very reasonable. It's certainly within plus or minus 15%. So at this point I've got to say that the secondary side of the coils are good. So you might have figured out by now that there's a reason this is called a wasted spark ignition system. There's actually two coils here, not one. And each of these coils is fired individually. And when it fires, for example this one, it sends a spark out one end to a cylinder that's in its compression stroke. And at the same time it sends a spark out the other end to a cylinder that's in its exhaust stroke. So obviously it's a wasted spark because it's going out to a cylinder in the exhaust stroke. So yeah, it seems kind of bizarre to me, but these things make, every time they fire, they make two sparks. They spark two spark plugs at the same time. The other coil here does the same thing. This is one coil, this is another. When it's fired, there's a spark coming out here and a spark coming out here. And one of those sparks goes to a spark plug that's on the compression stroke of its 4 cycles. And then this one, or the opposite one I should say, is firing a spark into the exhaust stroke of another cylinder. So far we've been able to check the secondary side of these coils. But this manual actually says that the igniter is integrated with the coil, therefore the resistance of the primary side coil cannot be measured. So they're not giving me any information on how to check the primary side. The primary side would be the controlled by the wires coming in from the electronic control module, the engine control module. And I have a block diagram here that shows that. Here's the coil, here's the module, and there's a wire that comes over from the battery down to pin number 2, so that provides the 12 volts to the coil. Then there's 3 wires coming out of the electronic control module, and I'm not sure what they are. It's possible one of them's a ground or a common. But then there's 2 that just go straight from the module into the ignition coil. And I'm thinking those are probably the 2 that control the primary side coils. So let's check that out with the ohm meter. Oh, and by the way, down here there's a diagram. This is E12, this connector on the coil. Down here there's a diagram of E12 which shows that when it's turned up this way and this notch is to the top, these are pins left to right, 1, 2, 3, and 4. And pin number 2 is the 12 volts, so I'll get on pin number 2. And pin number 1, I'm guessing, is one of the primary coils, and that's reading 908 ohms. And pin number 4 is another one that I'm guessing is a primary coil, and that's reading 911 ohms. So I think those are the primary side coils, and they're reading basically the same, only 3 ohms different. And so I think this coil is all checked out and it works good. I don't know why they said you can't check the primary coils, because I believe that's what I just did. If there's anyone out there who can confirm or deny what I just did, please let us know in the comments below. We'd like to know the actual details here if that's not it. Now I'm going to shift my focus to the resistance on the spark plug wires, or as they say in the manual, spark plug cords. These aren't cords, they're either wires or cables in my mind. So I'm going to go ahead and get these all popped out of their homes here. Nope, that one popped out pretty easy. That was number 3. There's some oil on the end of that. So I'm sticking my finger inside that spark plug hole, and I'm finding it's getting wet with oil. These spark plug boots go way down inside a hole in the valve covers to get to the spark plug, which is this far down inside. And there's a seal, there's supposed to be a seal, between the tube that this goes down in and the inside of the valve cover. And right at the moment, seems like it's leaking. And that's number 3. That was one of my weak cylinders. Well, let's see what we have on number 1. If I can pop that one out pretty easy here. We shall see. Yeah, came out relatively easy. And there's no oil on that one. So that's interesting. So let's see on this number 3 spark plug boot if there's any oil down inside there. Looks dry. Just using a Q-tip to see if there's any oil that actually got up in there, which might cause a problem, but it looks completely clean. So that's good. Okay, I was easily able to pull the boot out for cylinder number 1. This one's clean and dry. There's no indication of an oil leak. And if I can squeeze my finger down in there, there's actually a little bit of oil, but not like the other one. Let me see if I can push a rag down in there on cylinder number 3 in the spark plug hole there, just to see if I can clean up some of this oil that's in there. Yeah, I pretty much got it with my finger the first time I put it in there. Okay, now let's take a look at what the manual says about resistance on these. This came from cylinder number 3. It's reading 5.57 k ohms. Really? This says cord number 3 should be 7.7 to 13 k ohms. Take another run at that. .56 k ohms. So the resistance is a little low on this cable for number 3. Let's see what number 1 says. .77. And number 1 should be 7.1 to 12.1 k ohms. So that also seems like it's low. Alright, here's cylinder number 2. Pop that boot out of here. Oh, there's a bunch of oil on that one. Alright, well, we're going to check it for resistance anyway, of course. Clean up this oil. Got a little bit of an oil leak there. It looks like it's dry on the inside. It is dry on the inside. In case you can't see clearly, all I'm doing is checking the spark plug wires from one end to the other with an ohm meter. .7 K ohms. Cord number 2 should be 12.1 to 19.9 K ohms. So cord number 2 is garbage. And let's go for cord number 4. Number 1, 2, 3, 4. 4 is in the back here on the driver's side. On the left hand side, it's an American driver's side. And there is some oil on there. A bit. That's not bad. It's not wet in there. Let's take a resistance reading on cylinder number 4's spark plug wire. .25. It's 8.25 K. And according to the manual, it should be 12.3 to 20.2 K ohms. So maybe I need to replace this set of spark plug wires. It's kind of looking that way. They're way out of spec. Okay, so I've got one more thing to show you. This is like a bathroom vent duct flexible. It's just duct taped in there so that I can run without this piece. This piece being in there blocks all my access to the coil, which I have unbolted here. The engine's running, this is unbolted. This red wire here runs under there and up to the bottom and is tied to the back of the coil just to make sure it's grounded. So this enables me to run the engine. I tried running it without that pipe in there, that duct. It won't run because the airflow sensor here needs to see the airflow so the controller can create the right fuel mixture, air-fuel ratio. Alright, so here's a test to see if we have a weak spark on this coil. What I've done is I took a screwdriver and I just taped this alligator clip to it. And the other end of this alligator clip, this clip lead, is connected to the engine block. It's grounded. And so now a time, I'm going to pull these plugs off. And you can see that this thing has a very strong spark. That's like an inch away, more than an inch away. And so cylinder number 3 was one of my weak ones, I thought. But if I go ahead and pull this off of there, it's really not weak. I hope that shows up on the camera. And then the other one that appeared to be weak was number 2. So I'll check that one. That's got a good spark there. It's jumping out. It's actually jumping away from the screwdriver and going down to the engine. I think that's a good spark. Okay, let's do number 4 now. Have a good spark. Okay, I'm going to run through this again with less light and with the camera angle closer to the subject. You can see that spark jumps more than ½ an inch away from the contact in there. Probably jumping a full inch because that contact is down inside here. Do that again over here. That looks like a darn strong spark to me. If it was a weak spark, you couldn't draw it out there ½ an inch to an inch like that. It would fail.
Thank you for watching. Please take a moment to like and subscribe.